Hello everyone, in this video we're going to be talking about how to calculate the mass of reactants or products from an equation, and it's really aimed at those studying GCSE Chemistry, particularly in the AQA spec. It's one of two videos that I've done that look at kind of equations and calculations involving equations. So let's start straight away with one particular example. Now I've said from an equation, but I want to start with CO2, carbon dioxide. Now, let's just quickly put that down there. Let's keep it in the same format as I did in the other video. So C is the chemical symbol for carbon, O, chemical symbol for oxygen, and collectively we call this carbon dioxide. Now you can get carbon dioxide by heating carbon in air and it will form carbon dioxide. So there's our equation. Carbon reacting with oxygen to form carbon dioxide. Now let's say that we heat 24 grams of carbon and we want to know the mass of carbon dioxide produced. So here's our question. We've heated 24 grams of carbon and we want to know, there's a big question mark there, what is the mass of carbon dioxide we've produced? Now, again, if we look at the periodic table, we can see, so if we take the little square that represents carbon, it will have the symbol, and then it will have the name on the bottom, and then again, usually in the top corner, it has what's called the mass number, which represents the total number of protons and neutrons in an atom of that element. So that there is the mass number for carbon. Now what we need to do ultimately is work out what's called the relative formula mass. Now the relative formula mass is essentially obtained by adding up all of what are called the mass numbers, or more specifically the relative atomic masses of every element in a particular compound that you may have. I say relative atomic mass because you can look at the mass number of a particular element, but if there are isotopes, then what we do is we take an average of those mass numbers and we call that the relative atomic mass. Now in this example, because we're just looking at carbon alone, if we were to work out the relative formula mass of carbon itself, it would come out purely just as 12, because we just have the letter C. We're just looking at carbon individually. So the Mr, which is the symbol that we use for the relative formula mass, just of the carbon on its own, in effect, is 12. So the Mr for carbon, the relative formula mass for carbon on its own, is 12. Now if you did the same for CO2, the actual compound carbon dioxide, if we work out the relative atomic mass of the carbon, which is the 12, so this time we're looking at the Mr of carbon dioxide, what we need to do is take the relative atomic mass of carbon, which is 12, but we need to add on to that the relative atomic mass, if you like, the average mass numbers of the oxygens, and we've got two oxygens. Now if you look at the mass number on a periodic table for oxygen, it comes out at 16, so two of those would be 32. So we need to add 32 to the 12, and that comes out as 44. So you've got two numbers here, 12 and 44, and this is kind of how you would continue this question. What we say is, for every 12 of the carbon that we have, we end up producing 44 of the carbon dioxide. And if we were to do this in grams, what it means is that every 12 grams of carbon would yield or give 44 grams of carbon dioxide. Now the original question that we looked at in this example was, imagine we were to heat 24 grams. So if 12 grams gives 24, if 12 grams of carbon, gives 44 grams of carbon dioxide, then 24 grams, we'll just use the chemical symbol this time, of carbon we can see we've doubled that on the left side, so we'd have double the amount on the right. So that would give 88 grams of carbon dioxide. So for every 12 of carbon, if we're making 44 of carbon dioxide, 24 grams of carbon would create 88 grams of carbon dioxide, and that is your final answer. So let's very quickly just do another example to put this into another context, and then we can see how this one's worked out. So in this other example, let's say that somebody heats 200 grams of calcium carbonate, and that decomposes into calcium oxide and carbon dioxide. Let's just put the equation for that. So we've got calcium, which is CaCO3, and that decomposes when heated into calcium oxide and carbon dioxide. And we want to know how much calcium oxide can we make. So we want to know how much calcium oxide we're making after heating 200 grams of calcium carbonate. So again, we need to do this almost like a ratio. We need to work out what the relative formula mass, the MR, would be on both sides. So to work out the relative formula mass, we need the atomic mass of each of the components. So let's work that out. Calcium has a relative atomic mass of 40, plus carbon, which is 12, plus 3 lots of oxygen, so that's 3 16s. Because remember, oxygen on its own is 16, but we've got 3 lots, and that comes out as 48. So all of that added up gives us a value of 100. Now we need the MR of just the calcium oxide. We're not bothered about the CO2 in this example. So again, the relative atomic mass of calcium is 40. The oxygen here has a relative atomic mass of 16. So collectively, that gives us a relative formula mass of 56. And that's the MR, the relative formula mass. So again, hopefully you can see in this almost like a ratio that for every 100 of calcium carbonate, we get 56 of calcium oxide. And again, if we put a grams to it, it might make more sense. So for every 100 grams of the thing on the left, we get 56 grams of the thing on the right. And we were told at the beginning that we had 200 grams of calcium carbonate in this reaction. So if 100 grams of calcium carbonate produces 56 grams of calcium oxide, 200 grams of calcium carbonate, which is double, must produce, we'll just have it over on this side, must produce, I'll just quickly do this by ratio, 56, so 200 must produce 112, and it's grams of calcium oxide. And that is how you calculate the mass of a reactant or product from the equation. You just really look at the mass numbers, the relative formula mass, and you do it by ratios. So the original question was 200 grams of calcium carbonate heated decomposes into calcium oxide and carbon dioxide. How much calcium oxide do we make? We make 112 grams, because 100 on the left equates to 56 on the right. And we have 200, so we make 112. Okay, hope all that helps.